This is Sureka from S.A.E. Engineering College, Assistant Professor, Computer Science and Engineering Department. Now we are going to discuss about binary tree and binary search tree. I'll be first giving few introductions of terminologies over here about binary tree and binary search tree. Then we can go on with the MCQs so that it can be very useful for you to understand what's the concept, and behind that we can go on with the gate questions which will be very useful for you. Okay. We'll discuss these after I complete the introduction over here. Then I'll discuss the questions over here. So basically first we need to know what is nonlinear data structure. Since I'm teaching over here of binary tree and binary search tree, the concept which comes under the thing of nonlinear data structures over here. So first we should know what is nonlinear data structure. Nonlinear data structures are nothing but the items which will not be organized in a sequential way. So that's the nonlinear data structure. And into the concept of tree, what is a tree? It's a nonlinear data structure where the nodes or the axis of data which will not be in a sequential order. It's a recursive data structure where here the nodes will be in the form of parent-child relationship. It will be over here. And going into the terminologies, the basic things we should know of what is few things of over here. The root node, consider this is a tree where it will have the things of parent-child relationship over here. We have different nodes over here. So there will be only one node for a particular, there will be only one root for a particular tree, and here in this particular tree we will be having the root node is here A. The remaining nodes which is over here are the child of the particular tree. And edges are nothing but the connecting the different nodes. We will be saying that as your edges. Here A and B are connecting with the edge, and A and C it is being connected to a edge, and C and H. Likewise we go on, and this is your edge. And next is your parent. As we know, parent is a concept which is nothing but which is having a child. Either it can have a child or it can one child or two child we can have. And here A is the parent of B and C, whereas C is the parent of G and H. Likewise it goes. So next is your child. And here, as we were discussing in the last slide of what is a parent, here A is the parent, whereas B and C are the child of the child of parent A, and G and H is the child of parent C. Siblings, what is a sibling? Siblings are nothing but children of same parent. Here G and H are the siblings of parent C, whereas B and C are siblings of parent A. Leaf, here it's nothing but which is not having any children is a leaf over here. So here I, J, K are the different nodes which is not having any children for that. So this is your leaf nodes. And internal nodes are nothing but the nodes which is having only, at least they will be having one child. It is your internal nodes, or we will be telling that as your non-terminal nodes. So this is your internal node. Next, we need to know the important concept of what is a degree and what is height of the tree. Degree of the particular tree or degree of the node we can calculate. Degree of the tree here is nothing but the longest path it is having from, as it is discussed over here in the definition over here, the highest degree of the node among all the nodes in the tree is called the degree of the tree. So degree of the tree for this particular tree is which is having the highest degree of the node. So which is having A, which is having the number of edges is 1, 2, 3 over here, whereas here to reach here we will have only 2 edges over here. So the degree of the particular tree will be 1, 2 and 3. So degree of this tree will be 3, whereas particular node, if you want to calculate also we can calculate. The degree of C will be of, it's nothing but we will be having 2. The longest path we are going to calculate over here. levels are nothing but in tree we'll be having the parent-child relationship over here. So level 0, it will be starts from level 0 and it goes on with the hierarchical levels. Here this is your level 0, start with level 0, it will go on with level 1, 2 and 3. So we have 3 levels over here. Height of the tree, we are going to, again, as we were talking about the degree of the tree and the node, we should also know about the height of the node or height of the tree we should identify. So the definition which is over here, which is height of the root node is said to be the height of the tree. So height of the root node, how we are going to calculate is that edges from leaf node to a particular node. From leaf node we are going to go to the particular node. From leaf node, if you are going to take H, if you are going to reach the root node, it can have 1, 2 and 3. This is the height of the root node, that is your A. If you want to calculate the degree of height of your node C, 1, 2. The edges it is going to calculate. So from leaf node to the particular node we are going to calculate, that is the height of the tree. Depth, it's nothing but your root node to the particular node is your depth of the tree. The previous one which we were seeing is height from leaf node to the particular node. Here is depth is nothing but from the node to the leaf node we are going to calculate, that is your depth of the tree or depth of the node we can calculate likewise. Path, it's nothing but from a particular node to the node where we want to reach. If we want to come from A to J, the path it can have is from A to B, B to E and E to J is the path we can have. We have no other path from A to J. So it will come from A to B, B to E and E to J is your path. And we should know the thing, these are the different terminologies, the basic definitions we were discussing over here till now. Next we are going to see of binary tree data structure. Binary tree data structure is nothing but a tree which is having at most of 2 children. Either it can have 0, 1 or 2 children. It's your binary tree data structure. An example which is given over here, a node it can have, either it can have 0 children or 1 children or 2 children. At most it can have 2 children. That is your binary tree data structure. This is an example which is given over here. And we should know few things of binary tree, of what is a strictly binary tree. Strictly binary tree is nothing but either it can have 0 or 2 children. That is your strict binary tree. See this particular tree we have this G, it is not having any children, whereas D it is having 2 children. Either a particular node it can have 0 or 2 children, it's your strict binary tree. An example which is given over here, A which is not having any children over here. So whereas this asterisk is having 2 children over here. So strictly binary tree is nothing but it can have 0 or 2 children over here. Next is your complete binary tree, or it can also be called as your perfect binary tree. It's nothing but it should have exactly 2 children. That is your complete binary tree. An example which is given over here. Complete binary tree, each and every node will have 2 children. That is your complete binary tree or your perfect binary tree. And next we need to know the concept of what is binary search tree. Binary tree, it's nothing but, as we were telling, it can have at most of 2 children. Whereas here in binary search tree, what is that we are going to have is that the node, the root node, to the left of the root node it should have the children, what it is having should be of the less than the root node, it should be there in the left subtree, and the right subtree it should have the which is larger than the root node is your binary search tree. The definition which is given over here for binary search tree is that all the nodes in the left subtree will have the nodes that contain smaller values, where the nodes that is there in the right subtree will have the values which is greater than the root node. That is your binary search tree. So these are the basic concepts which we were discussing now before entering into the different questions in our gate. So with these terminologies and concepts, we are going to go and discuss about the questions now. So this is our first question. So what is the question which is given over here? They have given while inserting the elements which is given over here in an empty binary search tree, the element in the lowest level we need to identify. So as we were discussing in the previous slide of what is binary search tree is nothing but what? The root node, the left subtree should have the children's of smaller values, whereas the right subtree should have the values which is greater than the root node. That is your binary search tree. So accordingly, the elements which is given over here, first we are going to construct a binary search tree. From that we can identify what is the lowest level in the element which is there in the lowest level, we can identify it very easily. So what is the first node element which is given over here? It is 71. So always the first element will be the root node over here. So okay, we can start off with the binary search tree construction. The first node always will be the root node over here. So 71 will be the root node over here. What's the next node we are having? It is 65. So 65 we should compare it with the root node, whether it is lesser than or greater than the root node. Since 65 is lesser than the root node, it should come over here in the left hand side. So the next node is here 84. So always we should compare it with the root element. Here root element is 71. So which is greater than the root node. So we should have 84 in the right hand side of the tree. Again the next element is 69. We should compare again with the root node. 69 which is less than the root node. So it should come over here to the left. So again we are having a root node over here. So we are going to compare with this particular node 65 and 69. So 69 is greater than the particular node which is over here. So it should come over here in the right hand side. So 69 will come over here. Next we are going to have 67. Again we should start from root node. 67 which is lesser than the root node. So we should come over here to the left. We are comparing it with 65 which is greater than your 65, so it should come over here to the right. So again we are going to compare with 69 which is lesser than your 69. So 67 it should come over here towards your left. The last element we have is here 83. So what we are going to do is that again we are going to compare it with root node 71 which is greater than your 83 is greater than your root node. So it should come over here to the right. So we are again going to compare with 84 and 83. 83 is lesser than 84. So it should come over here to the left of your 84. So this is the binary search tree what we have constructed for the elements which is given. So what's the question we have over here? While inserting the elements which is given over here in any empty binary search tree. So now we have constructed binary search tree, and from this we are going to identify the element in the lowest level is. So which is the element in the lowest level? First we should know how many levels are over here. So this is always the root node which will be here in the level 0. The next level it will be of level 1, and the next level is your level 2, and this is your level 3. So the element in the lowest level is the question what they have asked. So the element in the lowest level is level 3 is the lowest one. So the element over here in the lowest level is 67. So the option we have over here is B, that is your 67. So the answer over here for this particular question is 67. Hope everyone you understood this, how you are going to construct a binary search tree and how you are going to identify which is the element which is there in the lowest level. So this is the answer for the question which is given over here. So this is the answer as we were discussing in the thing. The answer for this question is 67. So next we are going to go off with the second question. The question given over here is height of the tree is the length of the longest root to leaf path in it. The maximum and minimum number of nodes in a binary tree of height 5. So again what we are going to do is that they have given the height of the binary tree. Okay, since the height is given, we need to identify what is the maximum number of nodes in a binary tree it can have, or what is the minimum number of nodes in a tree it can have. So coming to that particular concept, how you are going to identify how many number of nodes it can have with the maximum number of nodes it can have. So which tree we can consider over here is that we can consider a complete binary tree. Why we are going for complete binary tree is that since in a complete binary tree only we will be having exactly 2 children for all the different nodes. So that's the thing which is given over here. So what is a complete binary tree? So complete binary tree is nothing but what? It can have exactly of 2 children. So this is how it should be. The complete binary tree, it will be like this. Okay. So which will have exactly 2 children. This is a complete binary tree. With the help of the complete binary tree, we are going to identify maximum number of nodes. So in this particular tree, if you are going to consider for this as an example, how many levels we have over here is from 0, 1 and 2 levels we have. The number of nodes for this binary tree, how we are going to identify? 0, 1, 2, 3, 4, 5, 6 and 7. So how many number of nodes are there in this level 2 of your binary tree? We can have 7. Maximum number of nodes we can have if the tree level is 2, and this is of the general thing we have considered over here, and we have calculated the maximum number of nodes for the tree we are going to consider of level 2 is 7. In general, if you are going to calculate, so here we have 1, here we have 2 and here we have 4. So how this can be given? So we can have 2 power 0, 2 power 1 and 2 power 2. So we will be having total of 1, and here we will be having 2 and here we will be having 4. So total 7. This can be simplified. How we can write this is that 2 power 3 minus 1. So this is the concept we have considered it for the level we have considered it for 2. If you are going to, in the question what they have given the height of the tree is 5. If we know the height of the tree, we can easily find out maximum number of nodes, the height the tree which is going to have the height 5. So let's see that. So if you are going to have height 5 for a particular tree which is a complete binary tree. So in general, as we were discussing, for the previous tree what we have considered, the level was 2. Here the height is going to be 5. So how we are going to consider is that we have a general formula for that, 2 power h plus 1 minus 1. This is the thing we are going to consider if we know the height of the tree. If we know the height of the tree, we can easily calculate the maximum number of nodes a particular tree can have. So here the height they have given is 5. The height of the tree they have given is 5. So how we are going to compute the maximum number of nodes with the tree which is having height 5? So 2 power 5 plus 1 minus 1. What is 2 power 5 plus 1 minus 1 is nothing but 2 power 6 minus 1. So it will be of 64 minus 1, it will be of 63. So the maximum number of nodes it can have for the tree which is having the height of 5 is 63. With this we can come to a conclusion with the options which is given over here is the option A. We can come to a conclusion this is the answer for this question, but we should also know how we are going to compute the minimum number of nodes. So let us now go on with that. So we saw how we should compute the maximum number of nodes for the given height of the tree. So now we are going to find minimum number of nodes if the height of the tree is given. We here know that the height of the tree is 5 and we are going to compute the minimum number of nodes, how much or how many it will have. So for this we are going to consider the skewed tree. What is skewed tree? Is nothing but it can be of a right skewed tree or left skewed tree. So if you are going to consider of your left to skewed tree, it will be like this. If you are going to consider we can have the right skewed tree, it can have like this. Since this is the tree, we can compute to calculate the minimum number of nodes. Since the height they have given here is 5, so we need to identify how many levels we can have for the height which is given as 5. So this is your level 1, 0, and this is your level 1, this is your level 2, and this is your level 3. The edges, how many edges we have over here is, this is your edge 1, this is your 2, this is your 3. The height they have given is 5. To consider the height of the tree as 5, this is your 4 and we are going to have this is your 5. To compute the minimum number of nodes which is with the height 5. So what is the thing we are going to consider over here is that this is your edge 1, 2, 3, 4 and 5. Height of the tree is nothing but what is the definition we were discussing previously is that to know the height of the tree or to know the height of a particular node, we need to consider from the thing of leaf node to the particular node we are going to have. So here the leaf node, from the leaf node to the root node, we have 1, 2, 3, 4 and 5 edges over here. So the height of the tree we have considered over here is 5. So with this we can come to a conclusion that the minimum number of nodes it can have for this tree of height 5 is that 1, 2, 3, 4, 5, 6. So the minimum number of nodes we can have for the height 5 they have given is 6. And in general we can have the formula for this is to find the minimum number of nodes is h plus 1. So height of the tree they have given is 5 and plus 1 if you are going to have, we can find the minimum number of nodes over here. So we can have the answer for this question is the A option. Maximum number of nodes we are going to compute is 63 and the minimum number of nodes it can have is 6 with a height of 5. So this is the answer for this question. So the next question what we are going to discuss over here is that the question they have given is a binary search tree contains distinct elements and has 1000 nodes stored in the form of complete binary tree again. So as we know already what is a complete binary tree, it will be of a perfect binary tree where it can have 2 children for each node it will be having. For example, we can have a complete binary tree. This is a complete binary tree. We already know this. Okay, this is your complete binary tree. Okay, so it's also a perfect binary tree. Here as they have given 1000 nodes we are going to consider over here. For having 1000 nodes for complete binary tree, the number of nodes it can have is 2 power n minus 1, whereas here it is not the case. They have given 1000 nodes which is of a distinct one. Here again, what is the question they have given? Indexing of CPT starts from 0. Find out the index of the third largest element they asked us to find. So to find the third largest element, we need to consider this is a binary search tree. So what is a binary search tree? Again, it's nothing but the element which is there in the left of the subtree from the root, it should be of smaller values, and the element which is going to be in the right side of the subtree, it will have the values which is greater than your root node. That is your CPT over here. To find the third largest element in your CPT, we need to go on with the right side element. So this is the tree we have taken, and with the level we are going to consider here again is level 1, 2. Okay, so for this particular level, the maximum number of the largest element will be over here in this particular place. So this is the largest element we will be having over here. So this is the first largest element. If we need to know the second largest element, we need to go to the previous level. So this will be your next second largest element of the tree. So this will be the second. So this will be the first largest element, and this will be the second largest element we are going to consider. And since they have asked for the largest element, which is of the third largest element in the index, so we are going to traverse over here. The third largest element which will be of this particular node, this will be of the third largest element. So this is the small complete binary tree we have taken into account, and we have found out the first, second and third largest. Since the question what they have given over here is for 1000 nodes they have given, we need to identify in which level we are going to get the first, second and third largest element. As we find this, these three values over here in the BST, what we are going to consider, from that we can find the index at which position the first, second and the third largest position, how we are going to traverse. So consider over here a complete binary tree again. So likewise we will go on. So for how many levels it will go to compute the third largest element of 1000 distinct nodes they have given over here. So we are going to consider level till 9. Why we are going to take till 9 is that, so for this particular level we will be having no number of nodes we are going to have is 1. For this node we are going to have the number of nodes is 2. For this node level we are going to have the number of nodes, it is going to be 4. Likewise it will go on. Till level 9 if you are going to consider, the level 9 if you are going to consider, it is nothing but 2 into so the number of levels we are having over here is 9, and it will start with the number of nodes we are going to have at the level 9. It starts from 512th index position, the level 9 will start. So this level it will go on till level 9 it will go. We are going to consider level 8 over here, and then we are going to consider for level 9. So in level 8 this would be the last node. Likewise it will go on over here in your level 9. This we are going to consider here is level 9. So here the index position it will start from 256 in level 8, whereas here in level 9 it will start from 512. So the elements we are going to consider, the nodes we are going to consider over here is 1000. So we are not going to consider the level 9 to find the third largest element. We are not going to consider this particular level of 9. We are going to go for the previous level, since then our third largest element, it will be should be there in the right subtree of the given BST. So we are going to compute this and we are going to calculate. Consider the previous level, the last index position will be of 512. So for example, so this will be the index of 511 since the next level it starts from 512. So we are going to consider this particular node over here, and this is the first largest element will be there in this particular position, and we are going to go for the previous one of considering this one. Here in this position we will be having the second largest element over here. The index position of this will be of 510, and we are going to compute the third largest element. It will be of this particular node with the index of 509. So this will be the third largest element over here. So what we can come to a conclusion over here is that the question what they have asked is indexing of CBT starts from 0. So the index of our CBT will start from 0, 1, 2, 3, etc. It will go likewise like this, and in level 8 the last node will have the index of 511, and we are going to find the third largest element we are going to find, and in which index position the third largest element it is there. So we now found out that the third largest element which will be in level 8 of the index of 509. So the answer for this question is 509th index position we will be having the third largest element over here. Before we go on with the next question, hope everyone understand this, how it goes on and how the complete binary tree it is used and how it is being calculated to find the third largest element and what is the index position the third largest element it will have. So answer for this is in 509th index question we will be having the third largest element. So the next question, we are going to have over here is about the traversal. So for the traversal of the elements over here which is given, the question is post order traversal of the binary tree is the thing they have given over here, and in order traversal of the same tree they have given. Now the question they have asked is the height of the tree is the length of the longest path from the root to any leaf. They are asking us to find the height of the binary tree for the above tree what they have given. So first we are going to consider of we are going to have the post order over here. What they have given is 8, 9, 6, 7, 4, 5, 2, 3 and 1. And whereas they also have given in order for the tree. In order is 8, 6, 9, 4, 7, 2, 5, 1 and 3. So from this we are going to have the tree. After we have the tree, we are going to find what's the height of the binary tree what we have constructed. So first we can start with post order and in order. So what is the rule we are going to have for post order is left, right and root. And for in order we are going to consider this left, root and right. So with this we are going to go on with the tree. So for the post order, the root element which we are going to consider is this one. So the root node will be 1 and we are going to come for the in order. Now this is a root node over here. We are going to find the left and right subtree over here. So if this is going to be the root, what is the in order rule they have given? Left, root and right. The right chain will be of 3 over here. So we are going to consider 3 over here towards your right. So now again we are going to go for a post order over here. So we are coming to post order over here. The next thing we are going to consider, this we have constructed. From these elements we are going to find which is the root element which will come over here to the left. So now the next root element will be of 2. So 2 will be the root of left subtree. Now again we are going to come over here to the in order. So this is your root now. The rule over here for in order they have given is left, root and right. So right of the root what we have is 5. So we are going to have 5 over here. Again we are going to come to your post order now. To coming to your post order over here, now we are going to consider these elements of what it should come to the left. So again we are going to consider the root of this particular left subtree. So since it is having the rule of left, right and root, so the next root will be of 4. So it will be of 4 over here. Again we are going to come towards your in order over here. Since this is a root now, right of this particular root is 7. So we will be having 7 over here. Again we are going to go over here. We have completed this. Now we are going to have these elements. The rule they have given over, we are going to consider this left, right and root. So 6 will be the root again. So we are going to consider 6 as your root. Next again we are going to come to our in order. So since this is your root, the right it will have 9 and the left it will have 8. So now this is our tree what we have constructed with the post order and the in order they have given. Now what is the question they have asked over here is, we are going to find the height of the binary tree. How we are going to find the height of the binary tree? As this is your level 0, this is your level 1, this is your second level, this is your fourth level and this is third level and this is your fourth level. The question they have asked is height of the binary tree above is. Now this is your tree for the post order and in order we have constructed. So how we are going to find the height? Height is nothing but height of the tree we are going to find is that from the leaf node to the root node or to any of the particular node we can find is from the leaf node to the particular node. Since they have asked the height of the whole tree, we are going to consider it from the edges we are going to consider, or we are going to consider the number of longest path it is going to have from the root node to the leaf node. So here we are going to consider the height we can have is 1, 2, 3 and 4. So the height of this particular tree is 4. So answer for this question is 4. So this is how we will be finding the height of the tree. If we are going to have the post order and in order, from this we can consider and we can construct our tree. After we construct our tree, we can find the height of the tree. Yes, thank you.